Hi, I'm Tom Niedermeyer with the AMF Training School. Welcome to our Partnership Program Maintenance Matters video series. Today we will be discussing the electrical operation of the Pinspotter. We're looking at the control chassis for this machine, sometimes called the brains. It controls the entire sequence of operation of the Pinspotter. And there will be times when our maintenance will require us to remove this chassis, either for testing or replacement. However, before the chassis can be removed, the power plug needs to come out. And as always, once the power plug has been removed, for safety, we should put it in a lock box so that no one else can turn this machine back on or attempt to turn it on until we're finished with the maintenance we are performing. So we've locked the box. This machine is safe. The chassis has several control plugs that we find here. The small one at the top carries the 115 volts into the chassis and also back out to run the various motors on the machine. Each of these plugs has a clip on each side that we must press in firmly and then ease the plug out, wiggling it as little as possible. Visual inspection of the plug would follow, looking for any pins that were burnt, bent, broken, pushed in, or pulled out. We do the same with the 50-pin plug on the bottom. This is the one that carries all of the machine switch wiring into the chassis. Chassis is held down by cam lock handles, one to the front and one to the rear. On the opposite side of the chassis, we find the mask plug, and also in this case a scoring plug, since this machine is wired directly into automatic scoring. Once the plugs have been removed, both cam locks have been freed, we can lift the chassis out of position. The table and sweep on the Pinspotter are controlled by combination motors such as this. They're called combination motors since they're used in the table and sweep position and on right and left hand machines. Here's a gear reducer attached so that the motor shafts will turn at about 12 revolutions per minute. Part of our maintenance then would have us changing the oil in the gear case, and some of the electrical problems could be the failure of a capacitor. This particular motor, a Franklin, has one of the two capacitors in its circuit mounted right to the stator. The second capacitor for this particular motor is in the chassis. What we're dealing with is something like this. Two of them, and they are used not only in the starting circuit but also in the electrical braking circuits. This particular motor, the Franklin, is solid state switched. Other motors, A.O. Smith, General Electric, or possibly National, used centrifugal mechanisms and centrifugal switches to put the start winding into and remove the start winding from the circuit in order to get the motors to run. So maintenance items would be centrifugal mechanism as well as the various centrifugal switches. The motors are controlled in part by cam switches on the front of the machine. These are used in the run circuits and generally used to stop the motor in a particular position. So the switches would be part of our maintenance item. There are 3 switches in this assembly, similar to this micro switch that we see here. The wiring from the cam switch assembly goes up into the wireway of the machine onto terminal strips such as this. From this point, they would go into the chassis. Inside the chassis, we would find control relays similar to this one. There are 2 of these in the chassis. One is used to control the table motor, the other used to control the sweep motor. These are low voltage control relays. That is, they only require 24 volts to turn the relay on. However, the relay contacts complete the 115 volt circuit to run the motors. One other device on the machines that operate off 115 volts would be the solenoid. The solenoid is used to control the spotting and respotting action of the Pinspotter. To get all of the wiring into the chassis, various chassis plugs are used. These also then would be maintenance items. The plugs can break. The terminals in the plugs can burn and need to be replaced. We see they come in different sizes depending on the particular location, some rectangular and others are actually round. Replacement terminals, both the male and female, are available so that they can be replaced should they need to be. Inside the chassis, we would also have 3 plug-in type relays. These are used to turn the machine on, used in various other circuits such as controlling the solenoid, possibly the frame meter at the desk, even sweep reverse in the microprocessor chassis. In the chassis that we have here, which is an MP chassis, there are 3 of those plug-in type relays. All 3 are identical, all 3 are interchangeable. We can see also that this chassis is protected by circuit breakers, 4 of them. They are not the same rating, so should one fail, we would need to be careful, making certain we replace the circuit breaker with one of the same value. This MP chassis also has a Program 0 button on it. This allows us to clear a problem should one develop in the circuit board that the program is not completed properly. This is the mating surface of the plugs that we looked at just a moment ago. Plugs and receptacles are not the same, as the identification numbers would be different. We would find separate part numbers then for the receptacle as opposed to the plug, so that these identification numbers come out correctly. Inside this MP chassis, we would find 1 circuit board and 1 only. There are a number of different generations of these circuit boards used in the MP chassis. This is one of the newest. This particular board has a number of LEDs on it, which will indicate the operation of the machine, showing what cycle we are in, whether the sweep is running, whether the table motor should be running, indicates what pins have been left standing, other useful information for the mechanic. These circuit boards contain a microprocessor that has the program that gives us our sequence of operation. When these boards are handled, the mechanic should be wearing a grounding wrist strap. This is to protect from any possible electrostatic discharge, simply grounding oneself to the chassis, putting the wrist strap on so that you and the chassis are at the same potential. These circuit boards are shipped in a conductive or neurostat bag. Once the board is taken from the bag, you should be wearing the grounding wrist strap. The board is in the bag, it is protected. The board out of the bag, it is no longer protected. This is a replacement board for the 5-board chassis. It's 1 board replacement, as it's often called, allowing us to update the 5-board chassis, making it compatible with scoring so we can have the shortened strike cycles. With a little additional wiring, this can also give us automatic sweep reverse with scoring, the same as with the processor chassis. With some of the newer machines, instead of having a start switch activated by ball impact on the cushion, we have a ball detector. This is standard equipment with the XL90 machines, and of course a ball detector can be adapted to any pin spotter. This eliminates the problems that can develop from lightweight balls failing to strike the cushion hard enough to cycle the machine. With the newer machines, XL90s, 8800 Golds, a camera is now part of the essential equipment for the machine. We no longer have wiring in the table to indicate when a pin is standing. This is automatically done by the camera. With scoring, a camera would be present anyhow, and we could use this for pin indication. However, without scoring, we would still have the camera with the XL90s because we need this to inform us when pins are standing. So now a camera is an essential part of the pin spotter. Here we have a manager's control panel. These were used to turn each machine on and off. We have a 3-position switch for each lane in the center. Center was off, up for bowl, and down for Instructomat. When scoring is installed, generally this panel is no longer used, and the pin spotters are controlled from the desk of our scoring device. Newer machines, XL90s and 8800s, use a completely different manager's control panel. With this particular type panel, you have many additional features, But with the newer machines, each chassis must be identified as to what lane it is on, since there's just one wire going to the entire bank of pin spotters. This way we can turn on one machine or every machine in the center with the actuation of one switch. This is used then on XL90s as well as 8800 Golds. The service manuals that are used with the pin spotters have all of the adjustments in them, as well as many drawings to make the electrical servicing of the machine much easier. However, there are special manuals dealing with just the electrical operation, such as this one for the 70 electrical operation, and this one that deals with circuit board components and the various schematics associated with them. There are also manuals dealing just with the electric motors, both the National and for the Westinghouse. These in an effort to make servicing by the mechanic much easier. This completes our overview of the Pinspotter's electrical operation. For more detailed information, you're invited to attend our training program in Richmond, Virginia.